Welcome to all. Myself, Vasudevan, M.Pharm, Assistant Professor in Department of Pharmaceutics, Sri Shanmuga College of Pharmacy, Sangagiri, Salem. We will discuss about the evaporation in pharmaceutical engineering. First of all, what are the evaporation in pharmaceutical engineering? The definition is the evaporation is the fundamental unit operation in pharmaceutical manufacturing that involve that removal of solvent from solution to concentrate the desired product. That's the major definition. The second point is that this process plays the crucial role in various pharmaceutical applications, from the producing syrup extract to formulate the advanced nanoparticle system, understanding the evaporation principle, the equipment section, essential efficient pharmaceutical production. These are all of the major points of the evaporations. And second one is the what are the objectives in this evaporation method? The evaporation serves as the multiple process in the pharmaceutical manufacturing, each the critical to producing quality product efficiency. What are the objectives? Main one is the concentration solution, the increase the active ingredient concentration in pharmaceutical formulation, and second one is the removal of solvent, they eliminate unwanted substance and the desired product specification, and third one is reduce the volume, bulk product to the consist reduce the volume, and third one is the and next one is a recover solvent, recycling valuable solvent for the cost efficiency and environmental sustainability. These are of the recovered solvents. And fourth last one is the prepare for crystallization, concentrated solutions, super saturated crystal formulation. These are of the prepare the crystallization process. And what are the application used in this the evaporation for the pharmaceutical industry? Majorly used is the various type of formulations like syrup, suspension, herb suspension, nanoparticles, solvent recovery, herbal extract, antibiotic productions. The syrups and suspension for the concentration of liquid formulation for the pediatric and adult medication. The herbal extract is the produce the concentration plant-based medicines and nutraceuticals. And the antibiotic production is the concentration fermentation broths for the antibiotic recovery. Solvent recovery, the recycling the organic solvent from the extract process. The nanoparticle formulation is the removing solvents from the nanoparticle suspension for the drug delivery system. These are of the application in the evaporation for pharmaceutical industry. What are the factors affecting the evaporations? Mainly affect the evaporation, the temperature, pressure, surface area, and nature of the liquid and heat transfer. We will discuss the one by one. The first one is temperature. Higher temperature increase the evaporation rate but may degrade the heat sensitive compounds. These the one of the main factors. And second one is pressure, reduce the pressure, lower melting point and enabling the evaporation at a low temperature. And third one is surface area, larger surface area increase the evaporation the rate through the enhanced vapor liquid contact. And fourth one is nature of the liquid, viscosity, density and thermal properties affect the heat transfer and the evaporation characteristics. And the heat transfer rate, efficient heat transfer is the essential for rapid and uniform evaporations. Okay, what are the understanding the process for differentiation? What are the difference between the evaporation and distillation? Drying. Uh, most of the process is the only for heat producing process, only for the drying process. Okay, major of the drugs is the separation. The first one is evaporation. The evaporation and distillation, and the three different purposes. Evaporation is the concentration of the solution, distillation is the separation of liquid, and drying is the complete moisture removal. These are of the difference for the purposes. What are the process for the three different process? The first process is the evaporation, removal of solvent from the dissolved solution, and distillation process is the separation of based on the boiling point and differentiation. Drying process is the removal of all moisture from the solid. What are the product used? This evaporation is a concentration solution. Distillation process product is a pure liquid compound, and the drying process compound is the dry solid metals. These are of the difference between the evaporation, distillation, and drying. Okay. One of the major important instrument for the evaporation, steam jacket kettle. The principles of the steam jacket kettle is the heat is transferred through the steam jacket surrounded by the kettle, the providing indirect and heating the solution. And what are the uses for this instrument? Production of syrups and elixir and herbal extra concentration and small scale formulation advantage, simple construction and operation, easy to operation, low initial investment and cost and easy maintenance and cleaning. What are the limitations? Slow evaporator, very slow evaporation rate and low thermal efficiency and slow, not suitable for large scale productions. What are the these all of the steam jacket kettle instruments? And another one is the instrument horizontal tube evaporator. The what are the principle? The liquid flow through the horizontal tube heated to the steam on the outside surface, and application primary used for the sugar solution and similar pharmaceutical product, and benefits the superior heat transfer compared to the jacket kettle with the larger surface area. The challenges for the difficult cleaning due to the tube configuration and potential fouling issues. Okay, another one instrument is the clipping film evaporator. The evaporator is the operating principle. What are the principle to the clipping film evaporator? The liquid is fed at the bottom and heated, causing the vapor to rise the rapidly and carry liquid film upward along tube walls. The ideal for the heat sensitive drugs and temperature label pharmaceutical compound requiring short resistance time. And key advantages: high evaporation efficiency, short contact time with the heating surface, the excellent for the thermal sensitive material. The limit, some limitations involved in the clipping film. The no suitable for the highly viscous liquid. Highly viscous liquid is not suitable for this instrument. To poor film formation and reduce the heat transfer. These are all of the clipping film evaporator. And another one small instrument, the forced circulation evaporator. These are of the four type of classified. First one is pump circulation system. The pump forces liquid through the heating tube at a high velocity, and preventing the scaling and fouling on heat transfer surfaces. These are of the pump circulation system. And second one is viscous liquid handling, the excellent for concentrating viscous pharmaceutical solution that would be otherwise full condensation evaporator. The scaling prevention, the high liquid velocity keeps solids in suspension and prevention deposits on heating surfaces. And fourth one is cost consideration, higher initial investment and operating cost due to the pump required and complexation system designs. These are of the forced circulation evaporators. Another one instrument, multiple effect evaporator. These are the multiple evaporator represent the finale of the energy efficient evaporation technology for large scale pharmaceutical production. The first principle is the vapor from the one effect is reused as the heating medium for the next effect, significantly reduce the steam consumption. And the second one is energy efficiency, that can achieve the 80 to 90% reduction in the steam usage compared to the single effect of evaporators. And third one is industrial scale, used extensively in a large scale pharmaceutical manufacturing for the maximum efficiency. The complex design is the required sophistically control system and carefully balance the pressure and temperature profiles. The economic calculation, the calculation is the efficiency of multiple effect of that is measured by the economy. The economy equal to kg solvent evaporated divided by kg steam used. For the example of triple effector about can be achieved the economy approximately 3:1, meaning the 3 kilo solvent and 1 kg steam used consumed. These all of the multiple effector. And thank you. These all of the evaporator system. We will discuss the another on by video. Thank you so much.